This is the brief on distributed control systems in nuclear power. So, what exactly is a distributed control system, or DCS? Well, you can think of it as the digital brain of a nuclear power plant. It's the thing that stands between human operators and the super intense reality of a reactor core. Okay, first up, how does this thing actually work? It all starts with a constant flow of data from sensors, checking temperature, pressure, and radiation. The DCS compares that live feed to its strict safety rules. If something's off, it immediately tells an actuator to, say, open a valve or fire up a pump. And if things get really critical, it triggers an instant, automatic shutdown. No hesitation. Second, why even trust a machine with this job? Well, it comes down to speed and safety. This system reacts to a dangerous spike instantly. I mean, way, way faster than any human ever could. And that keeps the staff safely away from the radioactive zones. Plus, it runs the plant at peak efficiency, 24/7, which, saves a ton of money. But of course, there's a catch. And finally, let's talk about the risks. These systems are really expensive, and they can be hacked. There's also the risk of some unforeseen condition that the programming just wasn't ready for. And that's why there's always a human supervisor in a remote room ready to override the system if it gets something wrong. So, to sum it all up, this automation gives us incredible speed and safety, but because code has its limits, human oversight is absolutely non-negotiable. The technology manages the danger, but people are still the ultimate safety net.
It's basically this smart system that uses sensors and an onboard computer to give your car, its own eyes and reflexes. It really takes a lot of the stress out of that stop-and-go highway driving. So first, let's talk about the setup. It all starts when you set a cruising speed on your touchscreen, let's just say 100 kilometers per hour. The moment you do that, lasers that are embedded right in your bumpers start firing out signals. And those signals, they bounce off the car ahead of you and shoot right back to your car's sensors. Okay, second is the calculation. Now, the car's computer isn't just seeing another car, not really. Think of it like it's using a super high-speed stopwatch. It's measuring the exact time it takes for that laser signal to make the round trip. And it uses that time to calculate the precise distance between you and the car in front. And finally, the system has to make a decision. It does this using something called actuators, which are just the physical parts that actually control your throttle and brakes for you. So if you're getting a little too close, the computer tells those actuators to slow you down. But if the lane clears up, it'll throttle you right back up to that target speed you set, constantly making these little micro adjustments to keep you safe. So really, this whole technology is just one constant feedback loop. It's measuring reflection time to manage your brakes and throttle, so you don't have to. It turns your car into a smarter, safer partner on the road.
When we think about automation in transport, our minds usually jump to, futuristic robot taxis. But the truth is, it's already working hard in the vehicles we control ourselves. Think trains that auto-brake. And probably the best example, self-parking cars. So first, how does this stuff actually work? Well, as you drive past a parking spot, the car's computer is already measuring it. It's kind of like bat sonar, really. Sensors in the bumpers send out signals that bounce off objects, and this creates a real-time 3D map. Then, these things called actuators, they're like mechanical muscles, take control of the steering, brakes, and throttle to just slide the car right in. Second, what are the upsides? Well, it's way more than just a cool party trick. It's all about efficiency. These systems park faster and can squeeze into tiny spots, which really helps keep traffic moving. And it's safer, too. The sensors can spot obstacles a human might miss, like a small child, and they'll stop the car on a dime if anything gets in the way. And finally, let's talk about the disadvantages. The system isn't perfect. Dirty sensors can cause malfunctions, and they often miss low objects like curbs. Hello, scuffed wheels. But the real risk is what it does to us. We can become so over-reliant on the technology that our own parking skills, they just start to fade away. So while automation offers incredible consistency and safety, it still requires maintenance and should never replace a driver's own vigilance. This is the brief on automated agricultural irrigation systems. We're looking at a case study from Brazil, and the scale here is just wild. We're talking fields over 10 square kilometers. It's all about managing water in remote spots where, manual labor just isn't practical. First, how does it all work? Well, data flows in from two places: automatic weather stations, which update every 10 minutes, and ultrasonic sensors that are measuring water levels in the irrigation channels. All that info gets beamed wirelessly to a central controller, which then tells these things called actuators to automatically start or stop the water pumps. Nobody has to lift a finger. Second, the efficiency is a really huge deal. This system protects workers from walking kilometers of channels in like 40-degree heat. And it's incredibly flexible. You can program it to flood fields for rice, while at the same time keeping the soil way drier for orange trees. And don't worry, a human supervisor can still monitor the whole process online and jump in to override the controller if they need to. Finally, though, we got to talk about the costs and the risks. You're trading general farm labor for some really expensive equipment and specialist technicians. But here's the critical blind spot. The sensors detect water levels, but they cannot see a physical blockage. So if a channel collapses, the system has no idea. It might overwater one area or completely starve another because it just can't see the problem. So while automation is a game changer for optimizing resources on these vast farms, it's still a high-stakes play that relies on deep pockets and good old-fashioned physical maintenance to succeed.